Hi everyone, welcome to Differential Calculus. Today we explore lesson 3.6, derivative of exponential and logarithmic functions. Number one, derivative of exponential function. Derivative with respect to x of b to the x is b to the x times ln(b), where b is more than 0 and b is different from 1. Here comes the proof. B to the x can be written as e to the ln b to the x, and we can simplify this to e to the x times ln b using properties of logarithmic function. So now the derivative with respect to x of b to the x is derivative with respect to x of e x times ln b. Use the chain rule. E to the x ln b multiply to the derivative of the inner function x ln b, and we have e to the x ln b multiply to ln b. E to the x ln b is exactly b to the x times ln b, and that complete the proof. Wow, let's apply it. 5y prime y equal 2 to the 1 minus x. Y prime is 2 to the 1 minus x times ln2 multiply to the derivative of the inner function 1 minus x. 2 to the 1 minus x times ln2 times -1, which is negative ln2 times 2 to the 1 minus x. Next example, y equal 2 to the psi square x. Y prime is 2 to the psi square x times ln2 multiply to the derivative of the inner function. That is the derivative with respect to x of psi square x. So I have 2 psi to the 2x times ln2 times derivative of psi square x is, well, chain rule again. 2 psi x multiplied to the derivative of the inner function. And then from there we have 2 to the psi square x times ln2 multiplied to 2 psi x cosine x. 2 to the psi square x times ln2 times 2 psi x cosine x is psi 2x. And that is it. Pretty slick. Let's move on to 2. Derivative of logarithmic function. Derivative with respect to x of log base b x equal 1 over x times ln b, where b is more than 0 and b is different from 1. Let's prove it. Y equal log base bx. From here we use the inverse property. And that gives us x equal b to the y. So now we can take the derivative with respect to x on both sides. On one side, we just used what we got earlier. Derivative of exponential function is b to the y times ln b times y prime, because y is the function in terms of x. Derivative with respect to x of x 1. So now y prime is 1 over b to the y ln b. And we know b to the y is exactly x. So it's 1 over x ln b. Yay! And that proves it. there is a pretty cool derivative, and that is if we set the base to be e, right, then we have derivative with respect to x of ln(x), which is the same as the derivative with respect to x of log base e of x, and that is 1 over x ln e, which is 1 over x times 1, and that is exactly 1 over x. So now we have a cool formula that we can use. Derivative with respect to x of ln(x) is 1 over x, and instead of ln(x), if we have ln of a function in terms of x, right? Derivative with respect to x of ln, let's say g of x, then this would be the chain rule, 1 over gx multiplied to the derivative within the function g prime x. Right? Another cool formula. Let's apply what we learned. Let's do some example. Example 5, f prime x in A. We have the function fx equal ln square root of x squared minus 1. It is best to simplify because we don't use the chain rule inside and then inside. Way too many inner functions. Ln square root is the exponent 1 over 2. X squared minus 1 to the power 1 over 2. Using property of logarithm, we take the exponent outside. So 1 over 2 ln x squared minus 1. And now we can take the derivative, which is 1 over 2 derivative with respect to x of ln x squared minus 1. 1 over 2 times 1 over x squared minus 1, and then multiply to the derivative of the inner function. 1 over 2 times 1 over x squared minus 1 times 2x, which gives us 2x over 2 times x squared minus 1, where we can get rid of the 2 here. And that just gives us x over x squared minus 1. Yay, got 1. In B, fx equal ln of the quotient x e to the x and square root 2x minus 1. Similarly, you don't want to do this directly because if we take the derivative using the chain rule, then the derivative of the inner function is pretty ugly. Best way to do this is simplify using property of logarithm. So ln x plus ln e to the x minus ln root of 2x minus 1. ln x plus ln e to the x is x minus, that is 1 over 2 ln 2x minus 1. And so f prime x is the derivative of each. Derivative of ln x plus derivative of x. That is the minus 1 over 2 derivative of ln 2x minus 1. So we have 1 over x plus 1 minus 1 over 2 times 1 over 2x minus 1, and then we multiply to the derivative of the inner function, which is the derivative of 2x minus 1. That gives us 2. So the 2 and the 2 cancel out, and now we have 1 over x plus 1 minus 1 over 2x minus 1. Yay! One more example. C. Fx equal to the product of root x, e to the x squared minus x, and x plus 1 to the power 2/3. Similarly, it is best not to do the derivative directly using product rule. So to do so, we're going to let y equal root x e to the x squared minus x, x plus 1 to the power 2/3. And we take ln on both sides. ln. We have ln y equal ln root x plus ln e to the x squared minus x plus ln x plus 1 to the power 2/3. And simplify half of ln x plus x squared minus x plus 2/3 ln x plus 1. And now we can take the derivative with respect to x on both sides. One over y and y prime. One over x, derivative of ln x, then we have to multiply to the 1 over 2. Derivative of x squared is 2x. Derivative of x is 1. Derivative of ln x plus 1 is 1 over x plus 1 multiplied to the derivative of the inner function, which is the derivative of x plus 1, that's 1, and multiply to the constant multiple, 2/3. One over y prime is 1 over 2x plus 2x minus 1 plus 2/3 times x plus 1. Now y prime is this whole thing right here multiplied to y. And that gives us 1 over 2x plus 2x minus 1 plus 2/3 times x plus 1 multiplied to root x e to the x squared minus x times x plus 1 to the power 2/3. Crazy. But we got the answer. Well, in this section, we're going to show something cool beside doing the derivative of ln x. And that is number 3. The natural number e as a limit. E is limit n goes to infinity. 1 plus 1 over n to the power n. Let's prove this. Let fx equal ln x. Then f prime x is 1 over x. So f prime 1 is 1 over 1, which is 1. We know that f prime x is also limit h go to 0. Fx plus h minus fx over h. So f prime 1 is limit h go to 0. f1 plus h minus f1 over h sub h equal x. Then f prime 1 is limit x go to 0. f1 plus x minus f1 over x. So now we do the substitution here. Limit x go to 0. The function is ln x. So f1 plus x is ln 1 plus x f of 1 is ln1 over x. ln1 is 0, so we'll have a limit x go to 0, 1 over x ln1 plus x, which is limit x go to 0 of ln1 plus x to the power 1 over x. Now we can let n equal 1 over x. So this is the same as limit as x go to 0, n go to infinity. N go to infinity. ln 1 plus 1 over n to the power n. Yay! And here come the awesome part. E is the same as e to the power 1, which is the same as e to the limit n go to infinity ln 1 plus 1 over n to the n, and then we use the property of limit, or the limit law. Well, you can take the limit n go to infinity e to the ln 1 plus 1 over n to the power n, and e and ln cancel out, so this limit n go to infinity 1 plus 1 over n to the power n. That is it. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.